asked question in Google interviews, that is to sum. It is a easy level question, and today I will be only sharing pseudocode. For the actual code, you can leave your comments. I'll be sharing the GitHub link with the actual code. So I'll be using Java to do all the coding here on this channel. So let's dive into the question. Okay, so let's start with the question. What does question says? So the question is very simple. It says you are given an array of multiple numbers, multiple integers, and you will be given a target. So you have to return the indices of pairs which sum is equal to the given target. Let's consider an example, that is 2. We are considering this example 2, 7, 11 and 15 and 9. The target is is 9. So we have to find such pairs from this array whose sum is equal to 9. That means how we'll do it, like without a coding, like how you will start looking for numbers. So easy way, like we will keep a finger on 2, then we'll check 2 plus 7 is equal to 9. Yes, it is. So what we have to return is indices of both the pairs. That is, for 2, let's mark the indices as well: 0, 1, 2 and 3. Okay, so the indices we have to return, so it will be 0 comma 1 is for 7 and 0 is for 2. Okay, so doing the same, we'll now go to 7. We'll check, or no, sorry, we'll stay at 2 and we will check if there further exist any pair, like 2 plus 11, 2 plus 15. I think there will be no pair existing apart from the single one. So let's just write it down, even though so let's 7 plus 11, 7 plus 15. Why we are not considering 7 plus 2? Because we already have considered. So I guess you guys are getting the pattern what we have to do. So there are multiple ways to solve this question. So we'll first go with the brute force algorithm, that is using the same technique what we discussed here. So let's say we will iterate over this array where I is equal to 0, I less than a dot a's array here, a dot length and I plus plus. Okay, so this is our first loop. So what it will do, it will put a finger on this element for understanding. Okay, it will put a finger on 2, and for putting second finger on the rest elements we'll need another loop, like for, let's consider another variable j, and j should not start with the 2. We should not put 2 fingers on this, right? So what we were doing, 2 plus 7, the next one. Okay, like here 7, then the next one 11. So what we will do is I plus 1. The next element we will do, we won't add the same element twice. Okay, so it will be j less than a dot length and j plus plus, right? And inside that what we will check, let's take a variable int sum is equal to a dot get I plus a dot get j, right? So if this sum equals to target, then what we will do? We'll simply return. We have to return an array, right, of length 2 that will contain indices. We'll use this list dot of and we'll pass I comma j. Done, right? So this is what we discussed here. So let's check for this is, let's mark it as brute force. Okay. So what will be the time complexity? If you'll see, we are selecting one element and then we'll looping the rest element inside, right? So for each element we are iterating the rest elements. Like for n elements we are iterating n minus 1 and so on, right? So the time complexity here will be on square tc, and same for space complexity here is order of 1 because we are not utilizing any space here right now, right? Okay, so let's go with the, let's try out to optimize it. I think many of you have heard about a data structure that is hash map, right? Most of you have heard about this, I believe. So what it does, it stores this thing. Just think of it like a key value pair. It stores a key. Let's say it stores key value pair. It's like you can store a string comma integer value, right? Let's say you want to store how much money does Ram have, so you can do Ram and money is 35. For Sita you can do 100. So in this way the data is stored, and this k and v is like key and this is the value, right? You have to define the types also here. Like for us it's like hash map string comma integer, right? So just for basic understanding I have told this. If you want anything further in detail classes about hash map, you can leave a comment. Okay, so we'll be using this in our optimization. So what we will do here, first we will declare a hash map. Okay, hash map will be of type int comma int, and let's name it map, and to initialize it we will give new hash map, right? Okay, so first we will do what, the similar thing. We'll put a finger like on any element is equal to 0, I less than a dot length and I plus plus. Okay, so after that, so let's discuss one more thing. What is complementary? So complementary will be like, let's say if I want complementary sum, so let's say I was given a target 9 and I am right now standing at 2 first, let's say, and this is plus x. So what I should add in this 2 so that it will become 9. So this x is the complementary, right, of 2, right? So for getting this x, what we will have to do is 9 minus 2, right? Simple algebra, it will be 7. So complementary of 2 will be 7, right? So that the sum is 9. So we will use the same technique. We'll do a int, we'll do a complementary. So we'll do target minus a dot get I. So for each element we will have a complementary of it, right? And we'll do a check if this if map dot contains the complementary, right? So that means if there is a complementary that exists in the given array, so that means there exists a pair, right? So we will return in this case a list of what? So if a complementary exists, because till now we haven't put any element in the map, so whatever is there already in the map should have already arrived first. So for returning in sorted order, so we will put this thing first, like map dot get a dot get I comma I. Oh, sorry, a dot, we will return it a dot, map dot get comp comma I, right? And if it is not found, we'll do map dot put comp, we'll put a dot get I comma the index value of it, right? So let's do a dry run with the example, same example, that is 2, 7, 11 and 15. Okay, and let's consider a map. Our map is empty right now. So let's say we are at this first loop, so we are at 0th index 2. So for 2 we come here, and what will be the complementary for 2? That will be 9 minus 2 equal to 7, right? So 7. So what we'll do, we'll come here, we'll check whether our map contains 7. So it will give us false, right? So it will come over this else. So what we'll do, we'll put 2 comma 0. 0 is index, 2 is the a dot get I, like this in our map, right? So what we'll do right now, after this 2 will come to 7, right? Now what will be the complementary? Here at 7, what will be the complementary? That will be 9 minus 7, that is 2. And we will come here, right, and we'll check whether our map contains 2 or not. So this get will be of order of 1 only. Okay, so this will be 2. For 2, yes, we have 2 in our map. That means there exists a pair for which sum can be 9. So what we will do, we'll come here and return the answer. So it is list of map dot get complementary. So get complementary 2. So it will be 0 and the I, that is 1. So, and the same is the expected answer here. Okay. So let's discuss about the time complexity now. So right now we removed this for loop from our optimized solution. So now only one loop is left, and this inner part is executed in order of 1. So the time complexity for this code will be order of n right now, but we have utilized some space, right? So as the array size increase, the space of this map will also increase. So this sorry, space complexity will be function of linear function of order of n, right? So I hope it was clear to everyone. That's all for today. For actual code, as I said, you can put a comment and leave your feedback. Anything needs to be improved, so we will try to improve it in next lecture.